everyone, and welcome in today's video. Today I will show you how we can model the previous question, which is solved by hand calculations using Autodesk Robot software, and how we can find the inflection points from the software and compare the results which we got by hand calculations with the one which the software is going to provide to us. So, in order to model the question, if someone remembers, in order to model the question, we're going to need the data for which we assume that the previous questions, which is going to be found in the description below of this video, where basically we assumed that force P is going to be 20 kilonewtons, force F, horizontal force, is going to be 15 kilonewtons as shown here, and then we assume that the length or the height of this vertical member is going to be 4 meters, and for the horizontal member we had a 3 meter length, and the supports are both pinned. So also we have to mention that the force is located at the center of these distances. So force P is acting at distance L over 2, and force F is acting at distance H over 2. So without any further ado, let's continue to model the questions. But in addition, besides that, I will also model the questions or the case. Besides that, I will also model case 0 and case 1 just for purpose of understanding on how to do it on a robot. So without any further ado, let's create a new model, and we choose again the frame 2D design, and let's just start. So the first thing, as we have done in the previous videos, is to define a member and to determine shape of our structure. So now we go here, and as mentioned, the vertical member's length was 4 meters. We just click again, and now we assign this node, and we go at distance 3 meters. So now we determine the shape of our frame. We can close this box, and the next step to be done is to assign the support conditions. So we go to the supports, we had a pin support, we choose this support here, and this is the configuration for it. We just select our nodes of interest, and now our structure is stable. So before adding any loads, we just need to create a load case. So we just go here, we just assign a dead load, and as well as we did on the previous video, I will remove, or we are not going to take into account the self-weight of the structure itself, as we are already assigned these members, as you can see here. So now we go to the load definition, but in fact before doing that, one good thing to be mentioned is that the force is located in the middle of this structure, and there are different ways on how can do it. For example, they can model the structure in this way by just having this type of members separate to each other. But besides that, there is also another way. If we go to tools, we go to customize, and we show the toolbars. We need to show the edit toolbar, and we have this option here which says division. So now I just want to divide this member in half, but I don't want to divide, let's say, the member, but I just want to assign a node in the middle of this member. So we just select this division into n parts. We have two segments which are going to be equal, and then we have this information here which says generate nodes without member edge division. So I do not want the members to be, let's say, divided. So let's just choose this one. We choose execute, and now we already have a node here. So if we show the node by clicking this number here, this option here, we are going to see that we have an assigned node. We do the same for the other member, and now we have exactly the nodes at the middle of the members without dividing the members. So now we can go to load definition, we can go to nodal force, and we said that this value here is going to be minus 20. We go in Z direction and we press minus 20. So now we successfully added a minus 20 kilonewton load here. Next, we remove the Z direction, so now we have a 15 kilonewtons acting on the positive direction. X, we just add 15 on X. And now we successfully added all the loads. So now we have to run the analysis. Everything seems to run smoothly and we have results. And let's go to remove the self-weight of the structure. We go to start again and we use recalculate. So now we have the results, and if I want to show the diagrams, I prefer this type of settings, as I've said it many times now, and they can show the bending moment function for the frame. So as you can see here, we have the inflection point and here. So in order for us to see where this inflection point is located, we can just select this member and we can go to tables, and then we are going to show the forces, for example, and let's say table filtered to the current selection for only for member 1. We just hit OK, and then we are going to have the forces, and on this gray area we are just going to right click on the mouse and then we choose the option table columns. We're going to have many options here for which we are going to use this division of points, and then we select characteristic points and we just hit refresh here, and one can see and read the location where the bending moment switches from positive to negative and vice versa, and for this case it's going to be located at 2.91 meters, which is correctly and exactly the value which we obtained by hand calculation. To check that, I will leave the link for the previous video on the description below. And next thing to be done is to check for the other member, which is going to be member number 2. And again, if we go to the forces, we just hit here member 2. We're going to have the results and the same procedure as before. We just go to the division points, we choose characteristic points, and we just hit refresh. And as you can see, that the location where the bending moment switch is assigned is going to be at x equal to 0.82 meters. In this case, we are going from left to right. So this is exactly the value which we obtained by hand calculation, which comes to say that the values which you solve parametrically are safe to be used, and even if these forces change, they will yield the same result. Now, if one wants to create separately case 1 and case 0, we can just easily do it by using the copy command. We hit select and we select everything. So now we go back here to the command, we just select one node and just click yes, and then we do the same thing here. And now basically what is left out is to change the support conditions for the first case, which now we're going to have a roller. We just select here, and also for the case 1. And now case 0 is completed, and we just remove these loads for case 1. This is case 0. Just delete, and then we just have to apply 1 kilonewton load in the horizontal direction. We just go to loads, we go to nodal force, we just add -1, we just select the node, and we already have this force here. Thank you very much for your time. I really hope you enjoyed today's video. If there is any questions, please leave them down in the comment section below. Please do not forget to like, share and subscribe. See you on the next video.